Hi, and welcome to the Kubernetes podcast from Google. We are your hosts, Abdel Sigiwar.
And I'm Caslin Fields.
Last episode, we spoke to some folks at KubeCon 2022 in Detroit, Michigan.
That was our first episode as the new co-hosts of the Kubernetes podcast from Google. And we had a lot of fun putting it together. I hope you all enjoyed it as well.
After this, we'll do just one more for 2022, and then we'll be back in 2023.
This week, Abdel had an interview that sounded really cool when he was telling me about it. Would you give us a little preview of what we can expect today, Abdel?
Well, we spoke to Louis from PGS. PGS is a company who's running Kubernetes with over 200,000 cores, which is impressive. They're also thinking about putting Kubernetes on floating boats in the ocean.
That sounds really cool to me. I know I've talked to a lot of folks who are interested in running Kubernetes in unusual environments. So I'm personally definitely looking forward to hearing this interview. But first, let's get to the news.
Docker has introduced a technical preview of Docker plus WASM. WASM, or WebAssembly, allows you to write code in many programming languages and run them inside a sandbox environment. The initial focus was on web browser, but has extended rapidly beyond browsers thanks to the WebAssembly system interface. With this preview, Docker wants to offer developers a complementary way to run containers depending on their use cases.
A security vulnerability, CVE 2022-39278, has been discovered in Istio that allows a malicious attacker to crash the control plane. The Istio control plane, Istio-D, is vulnerable to a request processing error, allowing a malicious attacker that sends a specially crafted or oversized message to crash the control plane process. This can be exploited when the Kubernetes validating or mutating webhook service is exposed publicly.
Google applied to introduce Kubeflow as a CNCF incubating project. The open source tool was released first in May 2020 and has developed into an end-to-end extendable machine learning platform with a large community of contributors and users.
SIG Store announced the general availability for the Recore Transparency Log and Fulcio Certificate Authority public benefit services. These services allow open source communities to sign and verify artifacts.
In exciting news, the CNCF introduced a new free course for Backstage. This open platform, which is used by developers to build self-services portal, have been part of the CNCF incubator since March of this year. The course is available from the link in the show notes.
I've also heard a lot about Backstage recently, so I'm also excited about that. And the CNCF also announced the availability of a new free intro course to Istio, the popular service mesh tool. The course is hosted on edX, or EDX, and is a collaboration with Tetrate and Tetrate Academy. And that's the news.
We are here today with Louis Bailleul, who is a chief enterprise architect at PGS. Louis have spent over 8 years working mostly on PGS high-performance computing infrastructure, HPC. And recently, with the company's shift to cloud since 2019, he's been focusing on leading the team of architects that focus on cloud migration. Welcome to the show, Louis.
Thank you for having me.
We've had a discussion when we were preparing for this episode, and there was quite a lot of interesting things and some very, very crazy numbers. But let's start with talking a little bit about PGS. What is PGS? What do you guys do?
PGS, we are a seismic acquisition company, seismic and processing acquisition company. So it means we have vessels that acquire data of the subsurface, and we process it to image the subsurface. And that's mostly used for like oil and gas exploration, offshore wind farm, and carbon capture nowadays.
Cool. Yeah, I've seen those vessels. They look very interesting.
Yeah, a lot of people say that we just cut the half, like the bottom half of the ship and just keep the front because they are like a triangle shape and they're very, very large. Like the biggest ones are like about 70 meters at the back.
Yeah. If people who are listening to us Google them, they look like the first couple of meters of like a regular vessel. So just like a triangular shape thingy. So let's talk a little bit about where did you came from to today running basically HPC on Kubernetes, right? And eventually running Kubernetes on vessels, which is one of the interesting, cool things you guys are thinking about doing. But let's start with the beginning. So you had your own data centers and you were running some supercomputers there. You had two of them, one called Bailleul and one called Galois, which I believe are French names, right?
Yes, they are a name of famous mathematicians, basically.
All right, cool. Galois sounded French to me. So I'm a data center nerd. I have worked in data centers before. I spent about 4 years in the Google data center, Europe West 1. If you have deployed things there, I've spent some time there. But I actually have never seen supercomputers. I've seen them on pictures, but I've never seen them in person. What are they? What is a supercomputer?
It's a lot of the same, a lot of different things. So it's still like CPUs, RAM, network, and all the stuff you find in any data center. It's just highly condensed. So in supercomputer, the main thing is basically power density. So cramming as much as you can in the same floor space of CPUs, memory, and everything. And also, it's most of the time use very specialized networking. So either InfiniBand or some proprietary fabric in order to reduce the latency node to node. In the case of Bailleul, which was the biggest supercomputer we had, it was 150,000 cores, 50,000 for Galois. It had the Aries network from Cray, so it was an XA40. So it's pretty big beast for us.
Yeah, maybe those references will resonate with some people who are listening to the podcast.
Yeah, it's a pretty select world, and there's not a lot of communication that's done outside of our world about it.
Yeah, that's interesting because whenever you actually Google supercomputers, you just end up on some obscure website like datacenternowledge.com or some like very dedicated HPC newsletters or publications that actually talk about them, right? So then, if I understand it correctly, a supercomputer is essentially like a bunch of servers cramped into the smallest space possible, but probably sharing some sort of control plane, right? So the motherboards are designed like motherboards, but they share they're connected to a control plane somewhere, right?
Kind of. So like in the case of the Cray XA40 that we had, basically on the same motherboard, you actually have multiple nodes, which are like a CPU and memory, and they share an I/O network, an I/O chip, basically, that is specialized for that network. So the Aries network is a butterfly topology, and it allows basically to have like node-to-node connectivity with extremely low latency and less than 2 hops from any node to any node in the network.
I see. Which means no switches between them?
So there are switches, but they are limited to as little as you can. And it's also like a source-based routing instead of being packet routing, packet switching.
Oh, interesting. Okay. Yeah, I've heard of that before. So then the question is, how different or how complicated are they to manage compared to like a regular fleet of servers? Like if you have, I don't know, hundreds or 1,000 servers.
It's the same, but one of the magnitude higher in the sense of how much you have to care about them. So the main reason why we have so much density and so much requirement for networking latency and interconnection is because the jobs that run on them basically are spread across all the nodes and participate in the same computation. So they use a framework like MPI, which allows sharing like actual code between the different machines to work on exactly the same dataset. Some even use RDMA, which is like raw memory access from one node to another in order to actually compute on the same memory space. What that means is that when one machine goes down, you can impact the jobs that run on 1,000 machines. And that's pretty impactful.
That's probably not good.
Yeah, you do have a lot of redundancies, a lot of things to take care of in order to make these things run. And so one of the aspects also is that these machines, because they are crammed so tight, they are water-cooled. So they are direct water-cooled.
Yeah.
And that add another level of complexity on the actual infrastructure you run into.
Yeah, the physical hardware.
Yeah.
Yeah, last time I checked, water and electricity doesn't go hand in hand in data centers. All right. And so you have mentioned also that one of these two supercomputers you had was on the top 500 list. I don't remember what was the ranking.
Yeah, we ranked 12th in 2014 when it was introduced.
Okay. So what is top 500? What is that list?
It's a list that gives you bragging rights.
Okay.
Mostly. But it's a list that is published twice a year, basically at ISC in Europe and the Supercomputing Conference in the US in November, which rank the biggest supercomputer in the world. So public ones, the one that we are aware of. And usually at the top, you find like national labs in the US or like a big European program or Asian program, like that national, basically, investment programs, basically, in supercomputer. So ranking in the top, 20, 30, even 50 is usually quite an achievement.
Okay.
Because like the top one usually like have investment that are counting in hundreds of millions of dollars, basically. And they have like usually an order or two order of magnitudes in terms of like performance compared to the next, top 5, top 10, and so on.
Yeah. There is something interesting with being in the tech industry and ranking things. It's quite an obsession that we have in this industry, which is quite fascinating, I guess.
Yeah, we like to compare things.
Yeah, we do. All right. And then around 2018, 2019, you started experimenting with moving part of your workloads to cloud, right? I mean, in this case was specifically Google Cloud, but it could be any cloud, essentially.
Yeah, we had a lot of experimentation in 18 and 19 because our crazy supercomputer were getting old, basically, and we are thinking about the next platform. So the problem with this big investment on premise is basically that you have a massive capex investment every 5, 7, 8 years, depending on how long you make it. But it's always a fairly hefty one, basically, that you have to replace because you have to go through a world supercomputer refreshes, network compute and storage that goes hand in hand, basically, that you have to just ditch and replace. And when we're looking at 200,000 cores, that's a lot of CPU. So if you do the math, it's a big investment in any shape or form. So we're kind of interested into lessening that capex investment. And then one of the idea was to target the refresh for the average utilization that we have. So on-premise, we used to be running about 80% full all the time. So we're thinking next platform, let's go for 80%. And for all the 20% that remains in order to process all the stuff we do through the year, let's go burst into the cloud and use the elasticity of the cloud in order to do that. So the experimentation with the cloud was basically under that angle is just to reduce the next investment cycle a little bit and optimize for the biggest efficiency possible on premise.
Yeah. So essentially, in a nutshell, it was buying eventually a smaller supercomputer and using the cloud as a bursting platform.
So smaller, probably not.
Probably not. But buying less than what you would probably buy if you aim for 100%, right?
Exactly.
So buy enough to cover the 80% use cases, which is through the year, and then use the cloud to burst for the extra 20%.
Yes.
I have seen people talking about bursting into the cloud, which is an interesting concept because obviously, there is a huge difference between a cloud platform and the supercomputer on-prem. I mean, there is already a huge difference between just regular servers on-prem and the cloud. But no, in your case, it's two totally different platforms, right? So the question is, how did that go?
Interestingly, it took a bit of time to get our footing. And as you say, the supercomputer on-premise is a very interesting beast. And there was no direct path. There is no way you can lift and shift your supercomputer into any cloud today. It just doesn't work. Well, technically you can if you go on Azure because they can rent you a cray, but you don't change anything. You basically just still running on the same platform. But if you want to go and use the elasticity of the cloud and basically pay for what you use, there is nothing that approach it basically. So we had to think a little bit. And one aspect where we're lucky in the early days is that we have the cray on premise, but we also had commodity compute that we use for a bunch of stuff, basically. Mm-hmm. So the vast majority of our compute power were basically coming from the craze, but we're still running workloads on standard compute nodes. So we focused on these ones early on as a way to burst into the cloud, saying that this will actually be easier to lift and shift because there was more commonality between the two platforms. That was okay in the sense that we took what we had on premise, which was the scheduler, the different library framework, all the stuff, basically how to run that on compute nodes and basically leverage the IS service over there. And we even ran parallel file system. We use Lustre on premise, which is pretty big file system type for our HPC workload. And we ran that on GCP, and we had pretty much all auxiliary services, databases, location services, the kind of stuff basically that you need. All that was running, and it was okay in the sense that it was functional. But in terms of cost efficiency, that was not great.
Yeah, I mean, it's a very interesting topic on itself, which is I've done some consulting before, and that's actually, when I was in consulting, that's where I met you the first time a couple of years ago, and we worked on some projects together. And at certain scale, especially at small scale, cloud sometimes doesn't actually make sense because you're just buying more expensive compute nodes, and you're not at a scale that gives you leverage to negotiate on one hand, so you cannot get discounts. You're just lifting from a server that you have already bought and paid for probably toward a platform where you have to pay monthly. And this is something that I have in my consulting time. I have came across with customers many times. It's oh yeah, it's more expensive. Well, it's more expensive because you're running 10 nodes, right?
Yeah, I mean, if you don't have an incentive to leave your on-premise, a real one, to go into the cloud for pure lift and shift, it's hard to justify the value. There's always things like you hear about, you got more flexibility or you have like a better path to innovation and the kind of stuff, basically. But if you do a lift and shift, you actually miss all of that. So you have to change things in order to benefit from the cloud. And it's the more you change, the more you benefit, but the more your actual engineering investment you have to go through. And it's a decision that you have to make.
Yes, that's what we use the very salesy term modernization for. Right? All right. And then at some point you said, well, I'm going to go Kubernetes, which is quite a huge shift from on-prem supercomputers, GCE on GCP, then Kubernetes. So what was that like shift in moments?
It was a long path toward Kubernetes, and it definitely wasn't something we had decided from the get-go. We ended up there more than we actually chose to go there. The main thing is basically like in 2020, we've been impacted like everybody, and we ended up in a financial situation that meant that renewing our on-premise platform was just out of question. There was no way we could actually do it with our finance at the time. So we had to find a solution. And because we've been getting our foot wet in the cloud and we're starting to see what was working and what was not, we were starting to see that actually if we go a bit further in, there is probably a way for us to completely shift our ID on its head, and instead of going 20% burst in the cloud, actually going 80% in the cloud and replacing the craze. So we started to explore that idea, and because we didn't really know what we didn't know and what we actually could do in the cloud, we started with the approach of taking what we knew from on-premise and looking at the different components that had like cloud interfaces or had cloud component that could be used. So we effectively did a lift and improve, would say, in that case. So we took a lot of the ecosystem we already had and started to build like cloud interfaces on it.
Yeah.
On premise, we're using Green Engine as a scheduler from Univa. At the time, Univa started to have a new product which was called NavOps Launch, which basically allow you to bridge your scheduler from on-premise with cloud resources. Mm-hmm. It was a very interesting way for us to burst because it was actually still using the same component we knew, all the interfaces we had from the user workflow were still the same. And it just basically bridged, how do you actually use the cloud resources?
Yeah.
So we experimented with that for a while, and we even had an MVP and even production running on this even today. But we eventually realized that at the scale we are, things that are not cloud native are extremely difficult to scale at the scale we want.
Yeah.
So anything that is actually trying to interface in a hybrid way or coming from a mindset or a technology framework that is completely different, it just breaks down. We're too big for this kind of thing.
Yeah.
So we eventually realized that we needed a cloud native scheduler, and we looked at what existed and said, hey, there's this little thing called Kubernetes.
I heard it can schedule things. Yeah, so that's actually quite an interesting shift of going from, and that's basically related to the point we said earlier, which is going from supercomputers and the user workflow, which you obviously don't want to disturb, to the cloud, which kind of does things in a different way. And trying to bridge that gap is quite an interesting problem to try to solve. So then you ended up basically having to build your own scheduler?
Not quite. The main problem that we had was basically that even Kubernetes is too small, or technically GKE is too small for us. So we ended up in a situation where a single cluster can scale to 15,000 nodes, but we need about 12 times that.
Yes.
So we ended up with 12 clusters. And one of the problematics that we had then was how do we move, actually spread the job across all these clusters? So we created what we call the external job manager, which is responsible for setting up workload inside the different clusters. And inside the cluster, we have an internal job manager, which itself is actually responsible for bookkeeping and actually scheduling the Kubernetes jobs. So from the batch API, basically, we use the Kubernetes job.
Yeah. There is actually a very interesting diagram in the talk you have given as part of Next 2022, which kind of talks or shows where this external job manager is and internal job manager is. And we will link it to the show notes so that people can look at it. But basically, my understanding is that the external job manager dispatch job across the 12 clusters you are running. And then the internal job manager will submit the jobs to the Kubernetes API, which then will schedule the actual pods, essentially, right?
Yeah, so effectively, we got two levels of job object, I would say. Like one that is at the cluster level, which is effectively like the actual namespace in which we run the workload, because we create a namespace dynamically per workload. Then you got the config map that comes from like the actual job user specification. And you got the services that are created in that namespace that are going to be needed in order to run that job. So we use Redis to actually like store do some accounting. And we have like the internal job manager, which is responsible for submitting the actual task to the Kubernetes. Yeah,
so that's the internal job manager. And then the external job manager is, my understanding is basically translates whatever the user submits and pin it to a specific cluster, essentially.
Yeah, so one of the interesting things is that because we didn't want to do a lot of rework on-premise and change how the user are operating and a lot of things like that, and we still had the on-premise to cater for.
Yeah.
So what we actually did is that we extended how the user submission workflow works to, at the end, instead of talking to a green engine queue on premise, it still talk to a green engine queue, but in it actually has a workload that is going to talk to Kubernetes and talk to the external job manager effectively.
Yeah. So you essentially built like an abstraction layer on top of multiple Kubernetes clusters.
Yeah.
And that abstraction layer are those like controllers? The external and internal job managers, are they controllers or they are?
Not at this time. So we experimented a little bit with like controllers and the operator patterns and a few things like that, but we are fairly new to Kubernetes effectively, and our like maturity for this was a little bit too low in order to support this kind of pattern. So today the EGM is basically just like a Python script that runs outside of Kubernetes that is effectively hosted in the green engine managed queue effectively. And the IGM is a simple service.
It's just an API.
Yeah,
Yeah, so basically this goes to say that not everything has to be a controller on GKE or on Kubernetes because like the controller and operator pattern is quite heavily used. And I have seen before people that end up running just many, many hundreds, thousands of controllers that just bombard the API server.
Yeah, we already have issues with the API server without going into this kind of thing. So
yeah, because you're actually running a very large scale. You're running 12 clusters at sometimes the biggest number of nodes you can get, which is 15K nodes per cluster, right?
Yes. Yeah, we've been getting cluster to their max, basically.
Yeah, and so that gets us to the numbers that you have shared actually in that presentation from Next. So I'm just reading out of a doc that I have prepared for the notes. At normal operations, you are at 200,000 cores, 21 petaflops, and 75 petabytes of storage, right?
Yeah, so that's what we spike to, basically.
Okay, that's what we spike to, okay.
Yeah. So it's, we had two records, basically, like one at the end of summer, so late August, and one late September, where we first reached 800,000 vCPU concurrently on about 50,000 instances. And then we reached 1.2 million vCPU, like still with 54,000 instances, just different instance shape, basically, that mean more vCPU.
Yeah, we're just changing the instance types. Interesting. Are those, I mean, obviously those are crazy numbers, right? 1.2 million vCPUs is crazy numbers. 53,000 nodes, is a big number. But are those like normal numbers for HPC workloads?
Yes. So it's in the high scale, but it's still like what you would expect from an HPC environment. To give it some perspective is like this 21 to 30 petaflops that put you in the top 25, like of 2 days, top 500. So it is not even one of the biggest thing ever. Yeah,
it's not very uncommon, which brings me to a very interesting question. I could not find you on the top 500 with the Kubernetes HPC, right?
Yes, because it's like the benchmark that you use to actually submit to the top 500 actually is not possible to run on the Kubernetes today.
Oh, so they haven't included the use case of cloud and Kubernetes.
No, this is one of the last things. So one of the big things that we need to mention is that going into GCP, we made the choice to go for the cheapest way to run.
Yes,
I would say. So the most cost efficient, which means that we're using preemptible VMs. So Spot nowadays has been renamed.
Yeah, it's called Spot now today's, yeah.
That means that the workload that you run needs to be able to survive preemption, so using checkpointing and so on. Historically, like when I was mentioning the supercomputer and what most supercomputers do is they run tightly coupled workload using MPI, which means that you create a ring between all the nodes.
Mm-hmm.
So that is very, very, incompatible with preemption. So running this kind of workload on like GKE is possible. You do actually have support in Kubeflow for it. But yeah, at the scale we have and with the cost efficiency we're looking for, this is not practical.
Oh yeah, interesting. So you choose to run on Spot VMs and you choose or you configured or you made your workload tolerate preemption, but for the sake of cost efficiency, essentially, right?
Yes.
Okay.
Yeah.
Quite.
Yeah, we it's just a toggle for us basically on using a different node proof.
Yeah.
Basically.
Yeah. And actually, the other interesting thing is you have done all of this with a very hard deadline for May 2022. With what was the size of the team? How big was the team that worked on this?
It's about 20 people.
All right. And you had from 2020 to May this year to get it done.
Yes. This was a very challenging effort and the team delivered like way above expectation for the complexity of the problem that needed to be tackled and the aggressivity of the deadline. So yeah, we're pretty proud that it was achieved, but yeah, it was a pretty big challenge.
Well, kudos to the team then. This brings me to my other question related to, so we of course we discussed these numbers and they're crazy, but there is this myth that people think that when you go to the cloud, you can just have an infinite number of resources, right? And they tend to forget that there are quotas that any cloud provider would enforce on you for many reasons. So how do you actually handle capacity management? How do you handle getting capacity when you need it?
It's a very good question. And this definitely is a myth that, everything is infinite in the cloud. Like, you technically just run on somebody else's computer. That's the bottom line.
Yes.
So you have the same capacity management issues than you would have on any other infrastructure. The only difference is that because of the scale of the cloud, most of the time you're not exposed to, its full extent. But for HPC workloads, you kind of get there.
Yeah.
So mostly we have contact with the capacity planning team, basically, which help us. There are definitely some interesting arrangements that can be made in order to accommodate for very large workload. Mm-hmm. So, for example, we run out of US Central 1, which is a very big region. Mm-hmm. But even within it, our clusters are basically tapping into different pool of compute. Mm-hmm. So they don't actually overstress the same resource pool.
Yep.
So you got different things like that. But one of the things that is making our challenge even harder is because we're trying to run out of Spot, which is extra capacity effectively on the cloud region. It is very unpredictable in terms of how much you can get. But with what we've been saying, you still can get a lot of it.
No, you can get 1.2 million vCPUs. So, all right, that's actually pretty cool. And then I'm going to shift gears a little bit and just talk about the other cool things you folks are doing, which is what actually we discussed first time we met, I think in 2019, Kubernetes on vessels. Like those boats we've been talking about, they are effectively a floating data center. They have computers on them, right?
Yeah. So the data acquisition is actually requiring quite a bit of processing just to do quality and to merge a lot of different data streams into something usable. Just for the operation of the vessel itself, we actually have quite a bit of compute. And we do some fast track, what we call, on the vessel, where we do some processing of the data into some intermediary product to get a sneak peek basically of what it will look like directly from the vessel. Yeah. And we've been thinking about the next generation of our platform on the vessel. And we have a few reasons for doing this. The cloud effort, cloud migration, cloud modernization effort, how you want to call it, that basically we started in 2019, impacted a lot of different areas. Mm-hmm. But as a general thing, pretty much all our IT functions or corporate functions start to shift and change. Some of them migrated to SaaS services, some of them been consolidated. So we see some change needed in here. The HPC being completely changed and moved into the cloud is also a good reason for us to look at the different platform. And because it's moving very heavily toward Kubernetes, this is a pointed thing. And lastly, we have new use cases now on the vessel. So over the last few years, we started to see a lot more machine learning and some edge computing proper edge computing that is done for like IoT.
Yeah.
So this kind of use cases have emerged from more modern platforms than traditionally. So we have a few reason to investigate.
Yeah.
It would make sense for us to deploy Kubernetes on the vessel.
Yeah, that's actually that's the cool part, right? Like having every vessel effectively a floating Kubernetes cluster, right?
Maybe not just one, but
maybe more than one. But this means that actually one thing when we were discussing is that most current on-prem Kubernetes installations, whether they're coming from a cloud provider like Google or whether even you want to do it yourself, you still need to be able to monitor it remotely, push software to it. But those vessels, they are on satellite connection, right? And they do not have a lot. What was the bandwidth you told me the other day?
The biggest we can get right now is about 10 megabits.
10 megabits per second. That is not a lot.
No.
So you have to be able to manage that Kubernetes platform on a potentially very low bandwidth, right?
Yeah, so reliability and then capacity of the connectivity is a challenge on the vessel.
Yeah.
And we do have some critical requirements for bandwidth. So there are things that have high priority that actually need to communicate with the shore and things that can wait.
That's a lower priority. Yeah. Yeah, so that basically creates another set of problems related to monitoring and making sure the environment works. And eventually it probably has to be self-healing. It has to be able to recover from a crash or something.
Yeah, so the current platform we have basically has been designed with a lot of resiliency in mind, a lot of cold spare, basically, and easy maintainability in the sense that we don't have an ops team standing by on the vessel. We usually have people that their day-to-day operation role is not maintaining a compute center.
Yes.
So it needs to be easy enough for them to, unplug this, replug that, and then off we go. We back in business.
Yeah.
Definitely a lot of self-healing and easy maintenance without being connected.
Yeah. The good news is Kubernetes on the edge seems to be a thing that people talk about these days. I haven't been at KubeCon North America this year, but the last episode we have put out online, there was a lot of talk about Kubernetes on edge and edge use cases. And we're seeing also multiple cloud providers actually moving toward that space. So there are potentially products that could solve these problems for you, hopefully.
Yeah, we've been looking. It's an emerging space. So we've been testing, we've been trying to get a foot wet with it. And we see that there is some good promises, but for the criticality of the environment for us, it's probably not ready yet.
Yeah.
We're quite happy to investigate further and follow suit because getting our different platforms converging toward Kubernetes is quite attractive as an idea. So if we can deliver on this in a way that is acceptable for the vessel operation, that's definitely good.
Nice. So we should expect in a few years from now you at KubeCon at a keynote talking about Kubernetes on vessels, hopefully.
Maybe.
All right, we will see. Well, thank you very much, Louis. It was great talking to you.
It was a pleasure. Thanks.
That was a really cool conversation and use case that you got to explore there, Abdel.
Yeah, it's quite impressive, the numbers that we discussed with Louis and also the size of the team they had to do the migration. It's pretty interesting.
Yeah, there's several components in there that I feel like I hear a lot of customers that I talk to also talking about. Things like the challenges of lifting and shifting to the edge and adopting cloud native practices to make the best use of the cloud native environment. I think I said edge, but I meant cloud. But another component is the edge. I hear a lot of users and a lot of customers that I talk to talking about edge use cases and how edge technology has really developed in the last few years. And I hear a lot of folks really interested in that. And like you said, doing this shift on a timeline with a limited number of people and limited amount of resources. It's a challenge that I hear a lot of customers trying to take on. And it's really exciting to hear this use case where they succeeded at moving to the cloud. And it sounded like he mentioned that their deadline was May of 2022 with only 20 people, but Yul didn't mention when they started. It sounded like about 2019.
They were experimenting starting 2018. They were doing POCs, but the actual start of the migration was 2020. because 2020 with COVID, they had a bunch of economical, challenges and financial challenges, and rebuying or reinvesting money into renewing their supercomputer, the Cray, that the supercomputers they were talking about, and they were end of life and they had to buy new ones. So instead of just investing money in buying new ones, which would be big capex, they decided we're just going to go to cloud.
I remember the early days of cloud when we were talking about, is the cloud really more economical for customers? And I love how you all addressed that. You talked about how at scale, yes, it can be. If you're kind of a really small shop that only has 10 compute nodes, it's probably going to be more expensive to move to the cloud. But at the kind of scale that we're talking about here, with using things like Spot and preemptible nodes, making use of the unique characteristics of the cloud, they actually could kind of save on their capex, which was really interesting.
Exactly. I think it's very interesting to keep in mind that there is still a little bit of capex because obviously they have a commit contract in order to get massive discounts. Most cloud providers do that. So there is still a little bit of capex. It's hidden. You don't see it, but there is still a certain amount of money you have to spend every year. But as you said, generally speaking, in my work on migrating customers to cloud in general, there is a confliction point where it becomes economical. It becomes interesting. As you said, if you have 10 nodes, or maybe go into a hosting provider would be cheaper than going to the big cloud providers, right? But 53,000 nodes at peak, 1.2 million vCPUs, that's a lot of nodes.
That's a lot of nodes. And I also love how you all dove into capacity management. A lot of the customers that I talk to kind of get bitten by that at first when they're starting to use the cloud, because like you all said, the cloud being infinite is kind of a myth.
Yes, exactly.
And so really you have these capacity management issues that you still have to deal with, and you have to make sure that you're working with a partner in the cloud that can actually work with you and make sure that you can manage your capacity effectively. So it was really cool to hear from them that they were able to do that with Google Cloud.
Exactly. And especially that actually the nature of their workloads are pretty unpredictable because they're pretty bursty. So when you are submitting a job, you don't necessarily know upfront how much you're going to need because they rely quite a lot on autoscaling as well. So once the workloads are deployed into the cluster, then the cluster autoscaler will spin up the nodes needed for that workload to run. So there was quite a lot of interesting discussions we had that didn't make it to the podcast. But yeah, it's a pretty interesting problem to solve when you are not in your own data center, right?
When you don't have full control over the capacity management, where things are placed and all of that, you offload some of that work for the benefits that you get from being in a cloud environment. I think that makes a lot of sense.
Exactly. I mean, and it's not like when you are in your own data center, it's easy to just increase your capacity, right? You still have to go through a sales cycle. You can't just buy hardware and have it just sitting on a shelf because it would depreciate over time. It's the same set of challenges. It's just as you said, you don't have control. So you have to solve it in a different way. Then
at the end there, you were talking about the future and how they're looking into maybe starting to run Kubernetes clusters on the edge on these vessels in the ocean. And with their limited bandwidth capacity, this is something that I'm hearing from a lot of customers and a lot of users, like I said, who are interested in edge computing use cases. There have been advancements in this area, like Louis said. So a lot of folks are looking into how they can do this today with the newer technologies that are coming out. And I know there are several projects in this area.
Yeah. So the interesting thing with PGS is that I actually worked with them back in 2018 when I was sitting PSO. I actually worked with them on a consulting project. And the project was on cloud, but the discussion about Kubernetes on vessels was happening at the time. There was just no product that could help them solve the problem, because one of the challenges with an edge use case, or their edge use case, is you don't have enough bandwidth, right? So you have to, of course, keep an eye on the clusters. You have to monitor them, but you don't have a big pipe from the vessel back to the internet. Then you have to have enough capacity to store data offline, because you're not going to be able to ship your logs and your data, which they do today. They store actually data on the vessels, and then when the vessel dock, they can just offload the tapes and read them, right? But when you think about telemetry data, like metrics and logs, you can just send this stuff over a satellite connection, which is 10 megabytes. So I think they're getting closer to that. They're looking at it very seriously. And I think that the main takeaway, at least for me, was the motivation for putting Kubernetes on the edge for them was unifying the software supply chain, how they ship software to production. Just using the same tooling, using everything, because basically you have Kubernetes as the base layer, right?
That's a really good point. And I think a lot of the customers that I talk to bring that up, is that you can run Kubernetes in the cloud and you can run it on-prem. And I have friends that have run it on ridiculous types of hardware.
Raspberry Pis.
So since it's such a flexible technology, you can have this consistency all the way through. So I think it makes a lot of sense for it to be popular there. I know there were some talks at past KubeCons about running Kubernetes at the edge and on interesting vessels and things like that. So I'll have to see if I can find a couple of those for our show notes.
Yeah, I think I remember from KubeCon Valencia, there was even Canonical, the company behind Ubuntu. They were there with their own custom hardware that runs Kubernetes. And each time I go to KubeCon, there is always like at least one or two companies with like some sort of colorful, like shiny computers, at the booth. That they're like, yeah, this is a Kubernetes. So you know what's interesting? The first time I heard about Kubernetes on the edge was reading a blog post by Chick-fil-A, the food chain in the US, where they wanted to do Kubernetes in stores, but they couldn't. So they had to come up with their own solutions. So they use this Intel NUCs, the small nodes.
Yeah, I have several of those sitting behind me, actually.
Yeah, I do have some here as well. So they had to automate it such a way that they could actually take a node. If one of their nodes in one of their stores break, they can just ship it to the store and have just a store employee connect it, and it will just bootstrap and connect it and configure itself automatically, right? So that was the first time I heard about it. And I was like, that's such a cool use case. And now it's actually a reality. There are products.
So awesome. As a contributor to Kubernetes and someone who works in the Kubernetes space, there's so much breadth to the use cases that folks use Kubernetes for. So hearing awesome use cases like this just makes me so excited for where the technology is going.
Yeah. I think Urs was not wrong when he said that Kubernetes is, what was it? It's the operating system of your data center, or the operating system in the cloud, right?
Yeah.
It's becoming this thing, which is like, it's a base layer. It's there, right?
Mm-hmm. And this is kind of going back to the beginning of the conversation, but when Louis was describing what a supercomputer is, he was saying it's just CPU and memory, and that's all connected basically with networking. And that's kind of just the basic components of compute wherever it is. And as he was talking about that, I was thinking, Kubernetes is like that. It's just about connecting CPU and memory over networking. So it's just kind of a base layer.
It's pretty much the same thing. Exactly.
Yep. Love that. So I really enjoyed talking with you about your interview, Abdel, and hearing you talk with Louis about this really cool use case.
Yeah, that was an awesome episode. I enjoyed talking to Louis, and hopefully we will get to talk to them again when they actually put Kubernetes on vessels.
I hope so.
That brings us to the end of another episode. If you enjoyed this show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on Twitter at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can check out the website at kubernetespodcast.com, where you will find transcripts and show notes as well as links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.